All right. I have taken some of the no brain too small questions because I figured you guys have started those, and I've been getting some questions on this one, and I've gotten questions on this one, so I figured I'd do those just to kind of help clarify. It also means that people can double check their work. I'll also do this one over here just so you guys can see how it goes in reverse. I think this is actually a pretty easy one though, so maybe I'll do a different one that looks a little bit harder, but I don't think. Oh yeah, this is a good example of one that's a little bit harder. I'll do that one. Okay. Actually, is it harder? I'm just trying. Oh, maybe this one. Okay. Anyway, I'll start with these two because these ones were both asked. So the first one is 2-methylbutanoic acid. I'm just going to write that word down on my piece of paper so we can learn how to decode that. Now, something that is bad news for you guys, because I know what it's like. I am a terrible speller. I'm not going to lie. I really can't spell. And unfortunately, with organic chemistry, they will mark you on spelling. So just be prepared for that. The reason why is because, like, if you change something from an A to an E, it changes what the function group is and stuff like that. So that's why they are going to be strict on the marking. All right. So to decode this information, the first thing I always look for is the parent chain information, because then that tells me how many carbons to put down, and then I can put everything down in reference. There's a head shaking already, no. So let me show you what I mean by parent chain. 2-methyl. If something's ending with an ill, like YL ending, that is talking about branches, so that is not the parent chain. The next word after that is our parent chain. We can see it's butan. So this here is my parent. All right, just to kind of refresh what we're thinking about when we're thinking about parent chains and things like that, let me go back to, actually this is the one I want. That works. There's lots of websites out there that will help you. So kind of keep in mind that you do need to have these memorized, and that is basically the carbon number, what name we assign it. So 1 is meth, 2 eth, 3 prop. A lot of these do kind of correlate to math, so the math terminology applies to this one. So like you say hexagon for like a 6-sided shape, it's hexane for a 6-carbon molecule. So it does parallel in those ways, so you don't have to memorize as many, because I'm hoping some of it's already built in as like prior knowledge. So just kind of keep that in mind. So when I'm looking at that organic molecule that we were doing over here, like I said, it has the YL ending. That tells me that's the branch. The next bit over here then tells me what the parent chain is. So let's just decode that. So that tells me parent chain, and I'm just going to annotate it so that we know. The ending bit to this is telling me the functional group, so the oic acid. And then the methyl, ethyl. So if we see basically the carbon number name with the YL ending, so that's telling me carbon number, and the YL ending tells me it's a branch, it just basically gives me information of how long that branch is. Okay? And then the last bit of information here are numbers. Numbers are really important because they can tell me what number carbon it's located on. Now, they don't always do that because it can be implied based on certain information. First thing I always do is I draw the parent chain, because that helps me figure out what's going on. So this is butanoic acid, so butan. That tells me 4 carbons. So I draw 1, 2, 3, 4. We go with that. All right, next step personally for me is I like to do the functional groups. I see that it has a carboxylic acid. Carboxylic acids can only be on N carbons, and we'll talk about why later in organic chemistry, but that's why this doesn't have a number on it. So you are assuming you know that it's on the N carbon. In this case, carbon number 1. Now, sometimes you can have multiple carboxylic acids, but if you do, it'll be on opposite ends. So if you ever see dioic acid, which you will come up with when you do organic, that just means you have 2 carboxylic acids, 1 on each end of the carbon. So, but Usually with the naming, they don't go that complicated. Doesn't matter if you want to put the carboxylic on the right or on the left, because it still is the same molecule. I don't know why, for my own personal preference, I like to just put it on the right. I don't know why, it's just how my brain likes it. You are allowed to put it on the left though. So that is the carboxylic acid functional group. You do need to memorize the functional groups. All right, since I have done that, I have started my assignments for the numbers of my carbons. So this is carbon number 1. This is carbon number 2. That's carbon number 3. That's carbon number 4. Are we okay with that? All right, you don't need to have the numbers on there when you're writing your answer. I'm just doing it to show you guys what I mean by numbering it. Remember, you only number it once. All right, next thing I'm going to be adding is my branches, or my only branch, and this is my methyl branch. So for methyl, it tells me you have a 1 carbon branch, and the 2 tells me that it's on carbon number 2. So this is carbon number 1, that's carbon number 2, so I must have a methyl. A methyl is CH3. And we'll start talking about filling in for the hydrogens. All right, something to keep in mind is that hydrogens, in order to be stable, need to have 4 bonds. Whatever they are, so you count how many bonds they already have, and then whatever is missing, you add hydrogen. These are known as hydrocarbons. That is why this is organic chemistry. So if I look at my N carbon here, that's the 4th carbon. It is currently bonded to 1 other carbon. So how many hydrogens do I need to get to 4? 3. So that's why I'm writing CH3. So 3, basically what I'm saying here is that that carbon has 3 hydrogens attached to it like that. Okay, that's the shorthand. That's much neater. I hate this, but I understand you guys will probably be doing this when you start learning because you're still trying to visualize what's going on. But this is easier for markers like me to mark it. All right, this carbon here has carbon number 4 attached to it. That's 1, and carbon number 2 attached to it. That's 2. So how many do we need to get to 4? 2. So that's CH2. All right, this carbon here, number 2, has carbon number 1. It has carbon number 3, and it has the methyl branch. So how many carbons do I need, or sorry, how many hydrogens do I need here? Just the 1. Get me up to 4. All right, this carbon here has 1 carbon, carbon number 2. So that's 1. It has the OH from the carboxylic acid. That's 2. And then you see how it has a double bond? 3, 4. No hydrogens on this guy. That's done. All right. Do you guys want another example? Or yes? Okay. Let me do the next one down. So that was the 3-bromo-pentanol chloride. All right, let's break it down. So, first thing, what's my parent chain? Pentane. So we see the pent here, and then how many is that? 5. All right, next thing is I have 2 functional groups here that is possible, that is allowed. My first functional group here at the end is a, which one? Acid chloride. Okay? The other one is a haloalkane. You are allowed to have multiple functional groups. So do look for it. Do I have any branches here? No, I do not. Okay? Next thing, numbers. We can see that the bromo is on carbon number 3, so there's a 3 in front. What carbon number is the acid chloride on? The end, because it's very similar to carboxylic acid. It has to be at the end. So this one is at the end. So we can assume carbon number 1. That's what we're going to assign it. All right, so going back to my colors, because I love to color code. 1, 2, 3, 4, 5. Agreed? All right, next thing I want to do is put my acid chloride down because that assigns carbon number 1. Again, for some reason, I like it on the right. Don't know why. Maybe it's because I'm right-handed. So an acid chloride is C double bond O and then Cl. That minor change from the OH to the Cl changes the functional group. So this is why I'm saying organic chemistry is really pedantic like that. Little mistakes mean you don't know what's going on. Adding an extra hydrogen means you don't know what's going on. All right. Next functional group is the bromine. So if I assign this as my carbon number 1, that's 2, that's 3, that's 4, that's 5. Okay? So carbon 3 is this guy over here. I'm going to be adding a bromine, Br. And then let's put in my hydrogens. I'm trying to remember what color I gave my hydrogens. It was green. All right, this one, how many? 3. This one, how many? This one, how many? 1, 2, 3, 1. See, if you wrote a 2 there, marked wrong.
You counted the bromine.
Because that's bonded to the carbon. Yeah? Okay, this one. 2. Last one. None. If you put a 2 here, it would be marked as wrong. So watch out for that, because then you're saying that the carbon has 5 bonds. All right. Do you guys need me to go in reverse and do a drawing and explain how I name it? Or are you guys okay now? Or you guys want to do some more practice? And come back to it. More practice? Okay. I think you guys are a little bit better now. All right, let's do more practice. And if you guys come up with more questions, I can do it in the reverse direction too. All right. Excluding Xander, I'm guessing you guys want me to go from a drawing to a name? See it in the other direction? Okay. Is there anyone in particular that you guys want? Because I feel like this is maybe too easy. And this one's probably too easy. That's an ester, so that's out of the question. This one's kind of a good one. It's similar to the bromine example, though, that I did. This one is completely different, though. How about this one? Let's do that one. Okay. Let's go in the other direction. Let me grab a piece of paper. All right. So, you have to go in both directions for this. So I'm doing this one here. Let me draw it down for you guys. I'm going to start it in purple. Should do it in a different color. No, we'll do purple. No. Yes. Okay. 1, 2, 3, 4. There was CH3, CH3, H, 2, double bond O. Okay, got it written down. Okay, so first thing we need to do is figure out the parent chain. So that is the longest chain with the functional group. Gentlemen, if you're not listening to me, that's fine, but you need not dog for the people that do need to listen. Okay, so we need to find the longest chain with the functional group. The functional group is, let me grab that in green because that's the color I was using. Here. All right, I have a C double bond O, and I have an NH2. That is my functional group. Do you guys remember which one that one is? Amide. All right, we got to have those memorized. Okay? So whatever carbon chain I do has to have the amide in there, and I'm looking for longest chain possible. Remember, don't just think because it's structurally drawn straight like this is necessarily the longest chain, okay? Sometimes they purposely do that to trick you guys up to make sure you can count. I don't like it, but they do it. All right, so in this case, this is carbon number 1. That's 2, that's 3, and that's 4. If I go down this way, do I still have the same number? 1, 2, 3, 4. So both of those are the same. Okay, so it doesn't matter which way I name it. They're both going to result in the same name. Both of these are methyl branches. Yeah, regardless of which one I use. This is a methyl. If I went down this way and I did 1, 2, 3, 4, that there is a methyl attachment. So regardless of which way I name it, it's still the same guy. Okay? The thing that's going to trick a lot of people up, and I'm going to write this down as a do not do this, is let's say you decide to number it 1, 2, 3, 4, and you decide to give the methyl the number 2, you'd be marked wrong, because if you said it was on carbon number 2, this is the one that gets the number priority, and so this methyl is actually over here, if you wrote that. Okay? Number it once, and that's it. And I'll repeat that one more time. If we numbered it going 1 to 4 this way, methyl would be on carbon number 2, right? But you have to go with the purple numbering because 1 needs to go to the amide. So if you accidentally wrote 2-methyl, you're actually saying that the methyl's on here, not on here. Okay? So don't use the orange numbering in that case. Okay. What else did I want to say? So, other things to keep in mind is I have a branch. This branch is what I'm going to use in my branch. That one is 1 carbon. So that one is a methyl as a branch. And I look to see what number I have. It's carbon number 3. So that's going to be 3-methyl. So I'm starting to put together my name. 3-methyl. The next thing I'm looking for is the parent chain and how long that parent chain is. It is 4, so it is butyl. And then I need to do the suffix for this. Now, with the amides, and you don't have to worry about adding the number because it's assumed to be on the N carbon and it's assumed to be carbon number 1. So 3-methylbutanamide is the name for that guy. All right? Questions, concerns, comments? All right, plan for Monday is I will start giving some work on the next section, which is on isomers, for those that are ready to move on. For those that aren't, can keep working on this. Huh? You're going to learn that next week. Esther's like having really terrible flashbacks.